Welcome to this screencast where we'll show an overview of the Coherence Demonstration application, which showcases many features of Oracle Coherence. My name is Tim Middleton and I'm a software engineer with the Coherence development team here at Oracle. The application we will show today is a fictional application based around stock prices, written in Java, and demonstrates many features of Coherence, including scalability and high availability, eventing capabilities, Polyglot client support, including JavaScript, Python and Go clients, disk-based persistence, parallel queries and aggregations, in-place processing, case store integration, Coherence Federation, which is a grid addition feature, and OpenTracing support. The application is web-based using Angular and Bootstrap, with the UI accessing Coherence via JAX RS endpoints. It can be run standalone on a laptop or deployed to Kubernetes via the Coherence operator. It uses the Oracle Bedrock framework to start and stop additional Coherence processes, as well as secondary cluster for federation. By default, the application uses Coherence Community Edition, but for the purposes of this demonstration, we are running using Grid Edition to showcase federation capabilities. We start the demo using the following command, which will start up a single server and bootstrap the application with 100,000 stock positions. The application UI shows information from a fictitious stock application, including the aggregated data, the times for carrying out the aggregation, the distribution across the members, and the number of servers that are started. We can perform various functions, including adding or splitting various stocks, monitoring prices, creating and recovering snapshots, and enabling federation, which is a Coherence Grid Edition feature. We'll firstly enable stock price updates, which will randomly move the price up and down. We will next add a number of cache servers and see how the data is automatically balanced. So add 3 cache servers. As the servers are started, we can see that the data is automatically balanced across the servers for high availability and scalability. While this scaling is happening, we can see that the data stays consistent while it's being balanced. And when the servers are started, we can see the time to query reduces as there are more cache servers available, and processing can now be carried out more efficiently in parallel. So we can see we've got the 4 servers started there, and then we can see the time for aggregation is reduced. Each cache entry has a primary and, by default, 1 backup stored as far away from the primary as possible. Depending upon your setup, you may have your backups across machines, racks or sites, providing a high level of availability in case of hardware or network failures. We can stop any of the cache servers and the data is retained as backups are promoted to replace missing primary data and new backups are made as required. We can see how the data is rebalanced in the background and consistent during recovery. Coherence provides the ability to listen for events on caches. In this application, we open a web page to monitor prices via server send events for all updates. You can listen for insert, update and delete events using specified keys or filters. In this case, we're just listening for all events. We can see the updates to the prices here. Let's now start federation. The federation feature, which is only available in Grid Edition, allows federation of data between geographically separate data centers for DR and additional high availability. In this case, I'm running this on my local machine and replicating between 2 local clusters for demonstration purposes only. There's no need to modify your application to take advantage of this, as it's purely done in configuration. In the demonstration application, we have a primary cluster called Perth and we have a secondary cluster called Sydney. So let's open the Sydney dashboard. So we can see here we've got the Sydney dashboard here, and the same amount of information, 100,000, has been replicated from Perth to Sydney. We'll now add 10,000 trades to the Perth cluster and see these replicated to the Sydney cluster. So we can see that these are now added, so 110, and we go over to the Sydney cluster and now we've got 110,000. As we have set up the cluster as active, we can add 5,000 trades to the Sydney cluster, and these will be replicated back to the Perth cluster. So I'll add another 5,000 trades here. We now see that there's 115,000. If we go back to the Perth cluster, you can see those trades have been added. We also have options to stop, pause, or replicate all data to get site into sync with the secondary site on startup. While we're looking at Federation, let's start our Polyglot clients. These clients connect via a configured gRPC proxy server and provide full API access to all of the Coherence functionality. For the demo, we have 3 clients implementing the same API. Firstly, we're going to use the Python client. So if I use Python 3 and run main.py, this shows the commands that each of the clients have. For the first one, we're going to use the monitor command, which sets up a map listener to monitor the prices from the Python client. From the Node or JavaScript client, we'll add additional stocks for a specific symbol. So if we run node main.js, we see the same option. So we're going to add trades, Oracle, OCL, and add another 10,000 trades. So if we go back to here, we can see in Perth, we've got 19,000 there. So we go back here, add 10,000 trades, and we can now see once that's updated, 29,000. And the final one, we'll use the Go client, and I've compiled the Go client into an executable. So if I run Go demo, we can see the same things here, and we're going to do a stock split. So for this, what we'll do is we'll stop the price updates for the stock split, and we're going to stock split del and do a 5-to-1 stock split. So what this will do is it will multiply the number of trades by 5 and then divide the price by 5. So it's running the stock split now. And we can see here now, there we go, the price has gone down by 5, but the quantity is still the same. Let's restart the price updates. OpenTracing is a standardized API for distributed tracing that allows you to monitor and track requests within applications. When enabled in a Coherence cluster, it helps you visualize and diagnose performance bottlenecks or failures by providing detailed traces of how data flows from the end-user API through the cache and any back-end data sources. What we're going to do now is to enable tracing in the cluster. We'll open up the Jaeger tracing UI and refresh that, and we can see we've got 2 services. We've got the Perth and the Sydney service. And we can see the Perth cluster here. Let's select some traces, and we're going to look at the get chart data. And what get chart data is the JAX RS endpoint. We'll select one of these spans and then narrow down the data. So we can see here that we've got the get chart data, which is a JAX RS endpoint. It does a couple of things, looks at size. It actually does an update of prices. And what that does, it invokes an entry processor to update the prices in the cluster. That's then processed here on member number 3. A backup has also been initiated, and that's processed on member number 1. So you can see the primary data is on number 3 and the backup is on another machine. And then also we can see we've got a cache store. So we've defined a cache store for this cache, which allows us to write the data through to a backend database, which is just an in-memory Derby database in this example, but could be any database. And we can see that we can also trace through the data. We can see the SQL update that happened on the database. So from the tracing, we can see we can get an in-depth view into what's happening within the cluster. Persistence allows you to automatically or on demand persist cached data to disk, allowing you to quickly recover data after a full cluster shutdown or as required. We've just taken our snapshot and you can see we have 125,000 positions. So I'll just check to make sure that it's running that snapshot now. It's just about done. So what that does is write data to disk in a consistent way. It's just about finished. So it's written to disk. And what I can actually do is I can actually clear that cache. So if I clear the cache, that will clear the Perth cluster as well as the Sydney cluster. So it's 0, and because we've got federation set up, we can see that that's replicated to the secondary side. Now what we can do is persistence. If you wanted to recover that snapshot we created, this automatically brings back the cluster to a particular point in time. So you do recover snapshot, and very quickly you can see that we're back to the same amount of data we had before, and we'll replicate that all to the Sydney cluster. We're back up and running. Thank you very much for listening to the screencast. If you'd like to know any more about the demonstration or coherence, please see the following links. Thank you.